What's up? I'm Vin, and today I want to take a look at the 1998 AP Calc BC multiple choice calculator section. So we're starting with this question here, and we want to find which integer k will make both of these series converge. So for the first series there, we have -1 to the kn over n, and what we need for this series to converge is we need k to be odd. So that's one of the requirements here, that k has to be odd, because then it's going to ensure that we have an alternating series. And in that situation, we'll have something that converges. If k is even, in that scenario, you're going to have just +1 over n like this, and this is the divergent harmonic series. So we could get rid of all the answer choices that have something even. So now we're just narrowing it down here to either k equals 5 or k equals 3. So if you look, if k is equal to 5, this is no good because k equals 5 in the second series would give you 5 over 4 to the n power, and this would be a geometric series where the radius is bigger than 1. So that one's out. So it has to be this choice here, because if you think about it, once again, I have 3/4 to the n power in a series, and this is a geometric series where 3/4, the absolute value of 3/4 is less than 1. So definitely choice D. So for question 77, we just need to know how to find derivatives. So we want to find the second derivative here, and this is a vector valued function. So the first derivative, we would have f prime of t equals, and the derivative of e to the minus t is e to the minus t times the derivative of the exponent is -1. So this would give us the derivative of our x component, and then the derivative of cosine t is -sine t. So then if I go to the second derivative, what I'm going to have here is I'm going to have -1 e to the minus t, and then I'm going to multiply by -1 again, which is going to change this to +1. And now I just have to know the derivative of minus sine t is minus cosine t. So in simplified form here, this is just going to be e to the minus t, comma, negative cosine t. So there's the second derivative, and this is going to correspond to choice E. So for the next question, we have the radius of a circle is decreasing at a constant rate. And for questions like this, when we have related rates, what I like to do is translate that stuff that I underlined in red into differential language. So I would say dr over dt equals -0.1 centimeters per second. And we want to answer here in terms of circumference. And just know circumference is equal to 2 pi times r. We want to know what is the rate of change. So what is the rate of change of area of the circle in square centimeters per second? So the rate of change of area, first we have to know the area of a circle. The formula is pi r squared. So if we find dA over dt, we're doing the derivative of r squared with respect to time. So we have pi times 2r, and then we have dr over dt. But if I rewrite this, this is 2 pi r dr over dt. Well, they told us in terms of circumference. So notice this component here. See how we have 2 pi r. That component we could replace with the letter c, and then dr over dt was -0.1 centimeters per second. But since ultimately here what we have is we're talking about the rate of change of area, the rate of change of area is going to be in square centimeters per second. So now we just look to the answer key, and this is going to match choice B. We have -0.1 times the circumference. That's going to be the rate of change of area in terms of the circumference. For question 79, we're trying to find the positive values of A that'll make f continuous for all real numbers. So for something like this, you have to think about what does it mean for something to be continuous? And that's when you have a function that is defined. The second thing that needs to be true is that the limit exists. And if I put it in the most precise language, that means if we're using the letter A, that the limit as x approaches A of f of x has to equal f of A. But the first two conditions are that the function has to be defined and the limit has to exist. So just know a function is undefined if it's in the form of a fraction, if you have a 0 in the denominator. So if we set x squared minus a equal to 0, I'm going to factor this as x plus square root a times x minus square root a. And this will tell us that x equals negative root a, x equals positive root a are values where f of negative root a and f of positive root a are undefined. So if we need to find a positive value of a, this tells us right away that no matter which value of a we choose, we're going to have something where if we plug in negative square root a or positive square root a, that our function is going to be undefined. So it's going to be choice A. And if you want to be really sure, let's say you plug in x equals 1. I'm sorry, A equals 1. When A is equal to 1, you could see that x equals 1 would make our function undefined. So that's why B is out. If we were to plug in something else, let's say we plug in, we're going to plug in this time A is equal to 2. Then if x is equal to square root 2, then our function f of x is undefined. So that's why C is out. And then here, since 1 didn't work, 1 and 4 is not going to work. And now if you were to try out here, let's say you plug in, this time around you plug in A is equal to 4, then x equals 2 would make our function undefined. So once again, there are no values of A that will make our function continuous for all real numbers because this condition can't be satisfied for continuity. So for the next question, we have region R is enclosed by the graph of this function, and then we have it's enclosed by the x-axis, the line x equals negative 2/3, and the line x equals positive 2/3. And we want to know the closest integer approximation of the area. So for something like this, the first thing I would do, since this is part of the calculator section, is I would just graph this. So I have 1 plus natural log, and I'm going to put parentheses to write cosine of x. I close the parentheses around the cosine term, then I raise it to the 4th power. And I'm just going to press zoom 6. So notice there's a lot going on here, so I only want to focus on the part of the graph that matters. So since I'm between negative 2/3 and positive 2/3, I'll go a little bit further out than that. I'll go from negative 1 to positive 1. So this is something that I like to do. And notice the height of my graph only goes up to positive 1 when x is equal to 0. So I'll just shrink my y minimum and y maximum. I'll go from, let's say, negative 3 to positive 3. So we'll make this a negative 3, and the maximum we'll make positive 3. And this way, you just get a much better looking picture. So when I have to go through a question like this, if I need to sketch this real fast, I just know my graph, I have an even function here, and that's just a rough sketch that we could use. So if I want to find the area of this region here, this is a scenario where it's defined by just one curve and the x-axis. So when I set up my integral, I'm going to have the integral of 1 plus natural log, and I have cosine to the 4th power of x like this. Now notation is not important because it's multiple choice, but sure, I'll write the dx here on the outside. And I'm going from negative 2/3 to positive 2/3 up here. So all I have to do then, I could go back to the main screen, and I'm going to press math 9, and we're going from negative 2/3 up to positive 2/3. And here's a nice little trick. You don't have to rewrite this all over again. I already wrote that in the y1. So I could press VARS, and I go to the right, and I go to function y1. And that way, once again, I don't have to type it all over again. And 0.919 would be the thousandths place approximation of this area, but to the nearest integer, that's going to be an approximation of choice B. So this is closest to an area of 1 square unit. So for question 81 here, we have dy dx equals square root 1 minus y squared, and we want to find the second derivative. So for this question, what we want to do is we could think of dy dx as 1 minus y squared all to the 1/2 power. So then the second derivative, d squared y over dx squared, we have to use the chain rule. We have 1/2, we keep the inside the same, subtract 1 from the exponent, and now you have to take the derivative of the inside, but the derivative of 1 minus y squared is going to be minus 2y dy dx. We just have to remember to use the chain rule. So then to close this question out, we just have to do a little bit of algebra. 1/2 times 2 will cancel. The 1 minus y squared to the negative half, I could call 1 over radical 1 minus y squared. And now what I have left is negative y, and dy dx is originally equal to radical 1 minus y squared. So this simplifies pretty nice. The square root terms are going to cancel out, and all we're left with is just 1 times negative y. So this works out to negative y, so 81 is going to be choice B. So for this next question here, we just have to know our integration rules, but the first thing I want to do is when I rewrite f of x plus g of x, I'm going to make a substitution and say that f of x is equal to g of x plus 7. And then I'm just going to write that initial plus g of x next to it. So we're just once again replacing f of x with g of x plus 7. And now what we can do is we could say that this is 2 times, so we have 2 times g of x plus 7 dx. But now I could break this up into two integrals. This is the integral from 3 to 5 of 2 times g of x dx. plus, and the 2 is only attached to the g of x term. So now I would have the integral from 3 to 5 of just 7 dx. But just know that one we can actually evaluate. If you want to use FTC, the fundamental theorem of calculus, to evaluate this, you can. Or you could just think that if you have the constant function here at y equals 7, the area between x equals 3 and x equals 5 is just going to be determined by this rectangle, where the base of the rectangle is 2 and the height of it is 7. So this I could just say is 2 times the integral from 3 to 5 of g of x dx, plus, once again, the area of this rectangle is just going to be the base times the height, and that's going to be 14 square units. So this looks like it's matching up with choice B. That's our solution to 82. So for question 83, we have a Taylor series for natural log x, and f is a function given by the sum of the first 3 non-zero terms of the series, and we want to know what is the max value of absolute value natural log x minus f of x on this interval. Now, your first instinct might be to go for the Lagrange error bound, but that's going to be way too much work, and for this question we get a calculator. We want to know what is the maximum value of ln x minus f of x. But the first thing we have to be able to do is say f of x is the first 3 non-zero terms of this series. So I would try plugging in n equals 1, n equals 2, and then n equals 3. And if we plug in n equals 1, you see how we got negative 1 to the 1 plus 1, which is negative 1 squared. We have x minus 1 to the first over 1, and now we're going to add. We have negative 1 to the 2 plus 1 is 3. We have x minus 1 squared, and this is going to be divided by 2. And then for the next term here, we have negative 1 to the 4th power. You can just see the pattern here. And then I got x minus 1 to the 3rd. And then I'm dividing by 3. So I'll just simplify this a little bit. This is going to be positive 1 when I do negative 1 squared. So I have x minus 1. And now this one's going to be a minus. So I have minus the fraction x minus 1 squared divided by 2. And then it's going to switch back to plus. This is an alternating series. I have plus negative 1 to the 4th power is making this positive, and then we've got x minus 1 to the 3rd over 3. So now I just have to go to the calculator and type this in very carefully. So I'm going math to the right to absolute value, and the first thing I'm writing is natural log x. So I have ln x, I close the parentheses around the x, and then I write minus, and now I'm going to write my parentheses, and I'm going to write this entire expression here. So I have parentheses x, wait, I got to go back, press the wrong button. So we have x minus 1. And the first one we have is minus. And if I want to write a fraction, I can press alpha y equals enter. That way I don't have to worry about any sign changes or anything like that. So I have x minus 1. This is being squared, and it's all divided by 2. I hit the right arrow to get out of the denominator, and then I got plus. I'll do another fraction, alpha y equals enter. And I got x minus 1. This time it's being raised to the 3rd power, and it's divided by 3. So then I'm just going to close the parenthesis around that term there, and you see the absolute value is at the end. So what I just typed in here, I have ln x minus f of x, but what I'm going to do next is I'm going to switch my window to go from 0.3 to 1.7. So I'm going from 0.3 to 1.7. And I'm going from negative 3 to 3, but let's see if this gives us a picture. So if I bring my window down a little bit more, I'm going to go y minimum negative 1 and y maximum positive 1, just so you could see that what we're trying to find is the maximum value. But notice here, the maximum value is occurring over here at x equals 0.3. That was the beginning of our interval that we wrote in the calculator. So now I would press second window, switch the independent section here to ask, because now when I go to the table, I could just type in 0.3, and this is going to tell us 0.1446 is going to be the maximum value here. And if we round it, that's going to be 0.145, and this is going to match choice C. So for this question here, one way I like to do these is to just plug in numbers. So I noticed here that choices A, B, and C are very similar. It's just the ends that are different. So what I would do is, let's say I plug in x equals negative 3. If I plug in x equals negative 3, I get this series. I get negative 1 because I'm doing negative 3 plus 2 to the n power over, I'm going to write that as n to the 1/2. And by the alternating series test, this series converges. Because it's an alternating series, the general term is decreasing and the limit of the nth term is 0. So that tells me the series definitely converges at x equals negative 3. So A is out, and now B and C are both contenders. Now, I'm going to get rid of choices D and E because this series doesn't go out far enough. If it converges at -3, this endpoint and this endpoint are just simply not accurate. But now the next thing that we need to check here is what's going on at x equals -1. And if we plug in x equals -1, now we get this series. We have -1 plus 2 is 1 to the n power over n to the 1/2. And this is the same thing as the series 1 to the n, or we could just say 1 over n to the half. And this is a p series where p is equal to a half, which is less than 1, so that series would diverge. So that means that -1 is not included, so that's why choice C is out. And for 84, this is definitely going to be choice B. Now, another reason why choice D and choice E are no good is you see how the radius only extends out here to -1, and it's not going to go all the way out to +1. And notice a number after -1 but before +1 would be something like x equals 0. And you see if we plug in x equals 0, we would wind up with this series. We would have the series 0 plus 2 to the n over radical n like this. And right away I could look at this series and say that it diverges because the limit of the nth term is not equal to 0 because the numerator is an exponential function while the denominator is a square root function. So because of this information, we could cross off D and E, and it's definitely going to be choice B. So for question 85, we have f is continuous, we have values of the function, and we want to use the trapezoid method here to approximate the value of this definite integral here. And these are the subintervals. We have from 2 to 5, from 5 to 7, and from 7 to 8. So what we could say here is that this integral is approximately equal to, so once again, we're using the trapezoid method. So what we have is we have 1/2 delta x, and in this case, you see the first delta x, I'll call delta x1 is equal to 3. Then the second delta x is equal to 2 because from 5 to 7 is just 2 units away. And then the third delta x from 7 to 8 is just 1. So I'd have 1/2 times the first delta x. And then what I have here is I have the sum of the y values. So I'm doing 10 plus 30 first, and that's just going to give us 40. And then we have plus 1/2, the new delta x is 2. And if we focus on the y values between 5 and 7 at the endpoints here are going to be 30 and 40. So when we do the sum of 30 and 40, that's going to give us 70. And then what we have next here, we have plus 1/2 delta x this time is 1. And then the last sum to look at here is the sum of the y values here between 7 and 8. So we have 40 plus 20 this time is 60. So then we could use a calculator for this, but this isn't too bad to simplify by hand. This is just going to make 20, and then 20 times 3 is 60. And then we have plus 1/2 and 2 cancel, we have 70, plus 1/2 of 60 is 30. So this is going to simplify to 160. So 85 is going to be choice C. Okay, so questions like 86 are particularly annoying because you have to be very careful with how you set them up. So we have the base of a solid is the region in the first quadrant, bounded by x, the x-axis, the y-axis, and this line here. So there's our region shaded in. And we're taking cross sections perpendicular to the x-axis. So that's a very important detail. If we're perpendicular to the x-axis, our equation is going to be in terms of y, but we're taking those cross sections. So let's say I take that red cross section out and I put it over here. Notice this represents the y value, but I'm building them into semicircles like this. So these solids are like almost impossible to visualize, but like if I lay this triangle out like this, I just kind of imagine like a bunch of semicircles going up like this. So it almost every time looks like a piece of cheese or something, but just know we're trying to find the volume of this thing, and the semicircles get bigger as you get closer to the y-axis, and the semicircles shrink as you get closer to the point 80 because the diameter of them shrinks. So now the whole game here is just correctly modeling what is the volume of one of these. Well, the volume of a semicircle is going to be, we have pi times the radius squared, but if the diameter is y, the radius is going to be y over 2. So I have pi times the radius squared, which is y over 2 squared. The thickness of this thing is dy, but we have to be very careful. This would be the volume of this if this were like a full circle. We're only taking a semicircle here. So notice we're taking a semicircle, so we would divide this whole thing by 2. So then the next thing we have to do here, we have an equation x plus 2y equals 8. We just have to do a little bit of algebra here and solve for y. So we're going to have 2y equals negative x plus 8. And now we have y is equal to negative 1/2 x plus 4 after I just divide everything by 2. So this is going to be our y term. So I could say that dv is equal to pi. And notice what I have here. I have y divided by 2. So if y is equal to this, I could say y divided by 2, I just divide each of those terms by 2, is negative 1/4 x plus 2. So I'm just doing negative 1/2 divided by 2 is negative 1/4, and 4 divided by 2 is 2. So now when I write all this stuff out, I'm going to have negative 1/4 x plus 2 squared, and the over 2 I'm going to attach to the pi like this, but then dy. So if I want to find the volume, what I'm going to do is I'm going to say the volume is the integral, and we're going from x equals 0 to x equals 8. So now I just have to very, very carefully plug this integral here that I'll box off in blue. I have to plug this entire integral here into the main screen, and that should be enough to answer this question. So let's go ahead and do this. We have pi divided by 2, and now I'm going to press math 9 for the integral. We're going from 0 to 8. And I have in the parentheses here, I'm going to write negative 1/4, which I got to write negative 0.25 like this, x plus 2, and that's being squared. The whole thing is being squared, so I put the linear function here in parentheses and square it. And I know they said dy, but whatever, I'll just write dx. It's not a big deal. And this is going to work out to 16.755, so that's going to match choice C. So just know, for these questions, once again, you just have to really, really take your time when you're describing the volume of one of these slices, and that'll make sure that when you're actually finding the volume of the whole thing, that's going to make sure that you're 100% accurate. For question 87, we want to know which of the following is an equation of the line tangent to the graph of f at the point where f prime equals 1. So first we should find when is f prime equal to 1, and to find that we're going to find f prime of x by using power rule, and that's going to be 4x to the third plus 4x. So we want to know, once again, when is f prime equal to 1. So we're going to set f prime of x equal to 1, and now set that equal to the derivative 4x to the third plus 4x. And now from here, what I'm going to do is I'm going to subtract 1 on both sides, and we're going to have 4x to the third plus 4x minus 1 equals 0. And now I want to find the solution to this, so I'm just going to type in, we got 4, and we have 4x to the third power. We've got plus 4x minus 1. And I'm going to press zoom 6 just to make sure this graph is in standard form here. And I'm going to zoom in a little bit more just so we get a better idea of where that point of intersection is. And our point of intersection is between 0 and 1, but to get the precise value, we press second trace option 2 for the 0, and we press enter before. We scroll after the root, we press enter a second time, we press enter a third time, and there's our x value. So a nice little trick, if you press second mode, and then you press second negative sign, and we hit enter, I could store that answer as the letter A by pressing alpha math. So this is just a nice little trick that, once again, every time I type in alpha math, it's just going to have this stored. Okay, that's just like a nice little feature here. So I don't have to keep retyping that in over and over. So now what I want to do from here is, remember, our slope is equal to 1, but we just found our x value is equal to, what we have here is x equals 0.2367329,039. So there's our value of x that makes this work. And if we're writing the equation of a tangent line, we also need a y value. So this is where we go back to the calculator. We have to type in the original function. And we have x to the fourth plus 2x squared. And remember, the derivative tells us the slope, but if I want to know what's the y value, I have to plug into the original function. So I press second graph to go to the table. And notice I'm in that mode here. If I go to second window, I switch this from auto to ask. That way I can manually input values. So I go second graph, and we're typing in the value for A, which was this entire decimal here. And notice my y value on the original function is going to be 0.1152. So if we round here, notice what we're going to have. We'll round at the very end. My tangent line is going to be y equals, the slope is 1, but I have x minus 0.2367329,039. And then I have plus my y1 here. I'm basically just using this formula. We have m times x minus x1 plus y1. So my y value is 0.1152. And that's going here. So then to simplify this, this is going to be y equals x, because I have 1 times x. And then I'm going to do this number here minus this value plus 0.1152. So we'll go back to the main screen for that. So I'm doing minus the a value, because remember I store this as the letter a, so I have minus a plus 0.1152. And if we work this out, see, it works out to minus 0.122 if we round. So we have minus 0.122, and this is going to correspond to choice D. So for question 88, what we have here is g of x is an area function, and it's the area under the curve of f. And what we have here is in the figure above, we have the graph of g on the interval from a to b. And we want to know which of the following could be a graph of f on the interval from a to b. Well, one thing to know here, if I want to come up with the relationship between g and f, I could use the fundamental theorem of calculus part 2, and I could say that g prime of x is just equal to f of x. Because notice if I take the derivative of this function from a to x of f of t dt, by the fundamental theorem, I could just say that that's equal to f of x. So that's basically how we're coming up with this here. So the connection we have to make here is we have to say the derivative of g, or another way of saying this is the slope of g of x has to match f of x. So notice here what I have is my slope of g of x starts out positive. So what that means is that f of x has to start positive. I'll just abbreviate. And then it goes to 0. It goes to 0. And then eventually the slope of g of x is negative. So that means if the slope of g of x is negative, then f of x goes negative, which I'll abbreviate. So if you look at all these answer choices, what is the only one here that starts off positive, goes to 0, then goes negative? Well, this one starts positive, goes to 0, then goes negative, but then you see it goes positive again between A and B. So that's why this one's out. This one starts negative, so I remember f of x has to start positive, so this one's out. This one here, notice it starts positive, then eventually it goes to 0 and it goes negative. So this is looking like a contender. But this one here is always positive, so it's out. And this one starts negative, goes to 0, and then ends positive. So this one here is going to have to be choice C. So once again, we're using the idea that if I want to talk about g prime of x, then I have to look at the slope of g of x. And that's going to be the route we take to answer here. So choice C. So for a question like this, it's very important that we show up to the AP test knowing our Maclaurin series for popular functions. So something like e to the x, we should know that that's equal to 1 plus x squared over 2 factorial plus x to the third over 3 factorial, and this goes on and on. But notice this function up here is almost the same thing as this, except notice everything that has an odd exponent has a minus sign instead of a plus sign. So the way that we can make these match is if we replace every x with a minus x, now this is 1 plus negative x squared over 2 factorial plus negative x to the third over 3 factorial, and so on. But notice here that it starts off as 1 minus x, but when I have a negative x in parentheses squared, I'm raising it to an even power. That's going to switch it back to a positive x squared over 2 factorial. And notice here I have negative x to the third power, which is an odd number. So this goes to a minus x to the third over 3 factorial. And the next one would be plus x to the fourth over 4 factorial. So really what they gave us here is the Maclaurin series for e to the negative x. So we want to know, when does this Maclaurin series intersect the graph of y equals x to the third? So what we're really trying to answer here is, when is e to the negative x equal to x to the third? And this is a pure calculator question. So we could just go here and write, we have e to the negative x, and then we have x to the third power. And these graphs should definitely intersect. And the setting I had it on before is conveniently able to show the point of intersection. So I press second trace 5 to find the point of intersection. And we press enter before, we scroll, we press enter after. And notice here, it's going to be at x equals 0.773, which matches choice A. So for this question here, we just have to know a few things about position, velocity, and acceleration. So we have a particle at the point 2, 0. It starts from rest and it's moving along the x-axis with constant positive acceleration. And we want to know which of the following could be the graph of the distance, s of t, of the particle from the origin as a function of time. So when they tell us the particle starts from rest, that means that the initial velocity at time 0 is equal to 0. But if this particle is starting at the point 2, 0, that's 2 units to the right of the origin. And if we're writing a function s of t that tells you the distance from the origin, the initial distance from the origin is just 2 units. So that's going to come in handy at the very end of this question. So we're also told that we have constant positive acceleration. So if I pick out a random value, let's say 3, this is a constant positive, then v of t would be equal to 3t plus, I'll call this c1. But if initial velocity is 0, that means what we could say here is that c1 has to be equal to 0. Because when I plug in 0, I'm going to have 0 plus c1, which has to be equal to 0. So c1 is equal to 0. So v of t is just equal to 3t. So the velocity has to be linear. And now the distance function here, I'm just going to go here and write, we have 3/2 t squared plus, and now we have a new constant. Let's say I call this one c2. So what I have here is that s of 0 is equal to 2, but s of 0 is also equal to c2. So that tells us that c2 has to be equal to 2. So a potential function would be something like 3/2 t squared plus 2, and I'll just make that a little bit neater. So that's a 3/2. And a sample graph of this, if I graph the whole thing, but I'll just graph t is greater than or equal to 0. It's going to start here on the y-axis, and it's going to go up like this. So that's why this has to be choice A. B, D, and E are automatically out, but the reason why it's not C is, remember, at t equals 0, this thing is starting a distance 2 units away from the origin. That's why it has to start up here. So for question 91, we have acceleration, and it's the acceleration of a car from t equals 0 to 6. And the velocity at 0 is 11 feet per second. So I'm just taking this information here and extracting it into function language. And we want to know the approximate value of the velocity at t equals 6. So this is what we want to find. And we're going to compute it using a left-hand Riemann sum. So the idea is that v of 6 is equal to v of 0 plus the integral from 0 to 6 of our acceleration function. So this is like a really nice piece of math to know, that we do the integral of acceleration to tell us the net change of velocity from t equals 0 to t equals 6, but we also have to consider what is the initial velocity at t equals 0. So here we have 11, and I'm going to leave the units out because it's multiple choice, and we're using a left-hand Riemann sum with 3 subintervals of equal length. So the subintervals you could see go from 0 to 2 to 4 to 6. So in this case, delta t is equal to 2. So what I have is I'm using a Riemann sum. So these are rectangles. So I'm thinking base times height. And the base of all my rectangles is 2 units long. And since I'm using a left-hand Riemann sum, I'm just going to use these 3 y values all the way to the left of my table. If I was doing a right Riemann sum, I would use 2, 8, and 3. But since we're using a left Riemann sum, I'm going to use 5, 2, and 8. So I just add these 3 values together. And this is going to be equal to 11 plus 2 times, and that's going to work out to 15. So this is going to be 30 plus 11, which is 41. Now, if you're not careful with this, a very common mistake here is people are going to choose choice B because they're going to forget to include the initial velocity. But just know the 30 represents the net change of velocity from t equals 0 to t equals 6. So it's very important, once again, that you consider the initial velocity. Otherwise, you're going to step in this bear trap here and choose choice B. All right, for this last question here, there's a lot going on, but we have a tangent line to the graph of f, and here's our function for f. At x equals 2 is used to approximate values of f of x. And which of the following is the greatest value of x for which the error resulting from this tangent line approximation is less than 0.5? So what I would do here is actually write the equation of a tangent line to this function at x equals 2. So what we have here is I have to find f of 2. And f of 2, this I could just plug in. It's not going to take too long. I have 2 squared minus 2 times 2 plus 3 is equal to 3. So my point is we have 2 comma 3. And now f prime of x is equal to 2x minus 2. So I need to know what is my slope at x equals 2. And if I do 2 times 2 minus 2, that's going to equal 2. So my tangent line here is going to be 2 times x minus 2 plus 3. So I'm just writing the equation of a line that has this slope of 2 going through these points, or the point 2, 3. So now just think about the concept of this question very carefully. I'm just going to draw something random here, but I'm in the neighborhood of x equals 2. I have some curve, and I want to know when is the error of my tangent line approximation less than 0.5. So essentially what I need to do is I need to subtract. I need to do f of x, the absolute value of f of x minus the tangent line. Okay, like that's the concept of what's going on here. And then what I'm going to do, well, you'll see, I'll do that first. So what I have is I have the absolute value of f of x was originally x squared plus 2x. I'm sorry, minus 2x. Let's make sure we write this correctly. That'd be a sad way to get this wrong. All right, so minus 2x plus 3, and then minus my tangent line was, and this I could even work out. This works out to, this would be 2x minus 4 plus 3. So just so it's a little bit easier to type in, and that's going to be 2x minus 1. So I'm subtracting 2x minus 1. And remember, this represents the error of my tangent line approximation, but I want my error to be less than 0.5. So now I graph all of this together. And notice what I need to happen here is I need my line to, the curve to be under the line. So I'm going to zoom in. And I'm going to use this zoom number 1 property here. You can press zoom box. And the way this one works is like you're cropping a photo. You press enter once. You scroll down, you scroll over, and then when you crop the photo in a way, it only graphs the part that you cropped. So you get a better picture of what's going on. So the question is asking us, what is the greatest value of x? So notice, once again, my error is less than 0.5 when I am under this line. Remember, in y1 here, I wrote f of x minus the tangent line, which represents the error in my absolute value. So when I'm under that red line, my error is less than 0.5, but I want the greatest value of x for when my error is less than 0.5. So what I'm going to do here is I'm going to press second trace number 5, and I'm looking for the second intersection point, because remember, I want the greatest value of x. I don't want the least value of x. So I trace this point of intersection here, and that's going to be at x equals 2.707. See, I got x equals 2.707, but now I go to the answer key. If x equals 2.707 is when the error equals 0.5, then that means I have to go here and say, well, this can't be it. This is going to be the biggest value of x because that's still, see, 2.7 is just a little bit less than 2.707. And these are not it because 2.7 is bigger than all the other answer choices. So this one is definitely going to be choice D. Okay, well, this is going to conclude this video on the BC Calc multiple choice calculator section. If this video was helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, just leave the topics you want me to cover in the comment section below. And thanks for watching.